suddenly falls onto some kind of elastomers. During that time you generate outside pulse. So then the test item that has to be mounted is mounted using some kind of fixtures. Test item is here, it is lifted and then dropped. So due to this method you get some kind of shock. This is studied for different shock levels, amplitudes, the kind of environment that you face. For example, we are just showing some pictures. There can be some kind of free fall shock missions, means you lift it to some height and then just simply drop. It is just like freely dropping, only that you have some controls. Here what is happening, the potential energy is getting converted to kinetic energy. Yes. And then you can also use some kind of shakers, like I mentioned, electrodynamic shakers for producing shock. You have a lot of advantages in generating shock from the shaker. That is, you can use different kind of shapes. You can have better reproducibility, and it has so many advantages. But there are some disadvantages also. That is, it can't generate very high velocity. The velocity requirements is less than 2 meters per second in the electrodynamic shaker, whereas it can go up to 10 meters per second or 15 meters per second in kind of shock missions. The stroke of the means that what we call displacement. There is a displacement limit, there is a velocity limit, there will be acceleration limit when we use electrodynamic shaker. And there can be amplifier limit in terms of power, that is voltage and current. Due to these limitations, shakers are not very good in producing the shock, but standard alone shock machines are there. We have designed and developed one kind of shock machine. It was for, there were some bigger rack systems, like where some kind of directions were not possible. That means, say, what we call is the sixth direction, that was not possible. So we have developed this, what we call as Bhadra shock machine. These are the issues that we had overcome in that. The objective was to design a 500 or 600 kg payload. These are the parameters. You can see, so you can click here. Click here. Here. Click. Okay, it's not. No. Actually, the mechanism is shown here. What it does is, it has some kind of cylinder here. It pulls this to certain height and drops it. So during that time, the required pulse is generated. So here also we have used the FP tools to design this, and we have automated it from the VC, and this system can be operated. The data acquisition, instrumentation, everything is automated, so that and integrated with the VC. We have used LabVIEW, the data acquisition system, and controls are all from the system. This is how we have designed. The parameter that we did was for this 10 to 5 energy, and it was pulse width was from 6 milliseconds to 30 milliseconds, and payload, and this was the form, what kind of shock wave that we generate is the offset wave, and the size of the unit that can be tested is 1 meter by 1 meter, and these are the what all required to be done. And see, when even in shock there were some failures. So for example, some of the Brembo systems are failures, so we have used isolator actually. So what this isolator does is, you can see here, sometimes it has done a very good work, it's a vibration, it has isolated, but it is a saying goes like a good vibration isolator is not a good shock isolator, it is a bad shock isolator. Sometimes you can see for 50G, some kind of input like 50G 5 milliseconds it isolated well. But for some kind of other inputs, the 35G 10 milliseconds, it did amplify input. Rather than 35, we got more than 60G. So we have to see, when you are selecting an isolator common for both the vibration and shock, you should see that both are getting isolated. You have to study both. This is again one system where it failed miserably. Like, once the shock vibration is taken care, one has to know the acceleration. That means whenever body moves in a curved path, whenever it is done, you get acceleration due to its radius. So that kind of system, what we simulate this environment is called acceleration, and that system is called centrifuge. Centrifuge has what it has one radius r, which is rotating about its fixed axis. So the acceleration that is generated is like r omega square. This r other designated radius is there. So velocity, the angular rotation of the system gives an acceleration. So what are the effects of this environment is given here. It can do a structural deformation, broken fasteners, shorting of circuit boards, delays to open and close. If there is any hydraulic pumps, it can have some cavitation effect. So we use some kind of centrifuge to do these tests. What we generate, what we have is like this. We have a 15,000, the specification is given in terms of G kg, it is acceleration payload. Here 150 G is the acceleration, 100 kg is the payload. Or you can take 150 kg payload or 100 G acceleration. So it is called 15,000 G kg acceleration mission with some other specifications where it can be generated. Apart from acceleration, due to the initial lift off, you get lot of sound that can have some process of failures, that is like fin oscillations. It can cause PCB failure and some kind of other systems can fail. That is what we call as acoustic vibration testing. So we have acoustic testing also, where we do in an acoustic chamber. The item is put and then we do some kind of testing. So we generate say around 159 dB, 150 dB or this kind of acoustic loads onto the system. Then we also have fiber shock. As I said, shock can be either mechanical shock or wire shock. Sometimes if the isolation is, the system is experiencing more levels, we can use some kind of isolators. You can see the amplitude at source and amplitude at the system level, and when we use isolator, what is the amplitude? Like this we can isolate the input. This is for underwater shock test. Right. Apart from all these tests, one has to say there are model testing, very important one in the sense that it validates the design. And what is the model testing is, when you do model testing of any structure, you get three things. You get natural frequencies, you get mode shapes, and you get damping. So these three can be evaluated from the model testing. Basically, there are different types of model testing that are done by us. Say one type of testing I will show you. What we do, same thing. So say for example, one of the Bhadra missile physics, we had done a full complete missile model testing. We get these. These are fed by the control electronics for controlling control and guidance. These are important actually for control guidance engineer. These parameters are required for him to control the mission during its trajectory. What he needs all the information of the first and second mode and its damping. This is what we need actually. I will show you. Kinetic heating again I told you. When the system is re-entering, you need to have very high temperature profile to be simulated. We did some of the systems. Then apart from that, we have some kind of transportation and road vibrations, where the total missile is transported at different roads conditions, and we simulate which what is the speed, outbound speed that is better for that. Now that we have seen outbound speed. Yes. Click on it. You can see one of our missile what we have done. In model testing, as I mentioned you before, you need three things. That is natural frequency, mode shape and damping. What we do in the model testing is, you have to give input to the structure at some points called anti-nodal points and measure its deformation along the length of the missile arms at different points. So we have put some kind of sensors, you can see different sensors, number of sensors we put, and we give input and simultaneously acquire all of them, and then after some processing of the this accelerometer data, you can get some kind of shape like this, which tells you when the input is given to the system, how this system bends or say behaves. This is what is called the mode shape. And apart from that, you will know at what mode shape, what frequency, what is the damping and what is the mode shape. So these three parameters are very critical and important for us to be evaluated. So we do this. You can see a video where we have put lot of sensors, number of sensors, and then we use some kind of excitation at some point and collect all the data. We have put along this number of data. You can see these are what we call accelerometers. This is what we call accelerometers. I'll show you what was the last one. This is the Airbus model. You can see the Airbus A380. What they do for their model testing. Model testing is very important tool for validation of design. You may do so many designs. If you want to know whether your design is correct or not, the simple test that you can do is the model test. Here you see that such a big structure is being driven by a small shaker. They also do the same thing. They put these are what we call accelerometers. Number of accelerometers at different points. The entire system, aeroplane's dynamic characteristics can be known by exerting at very small point. And then a lot of information it gives to the designer and the confidence this test gives actually, model test. These are the number of accelerometers. You can see how they are arranged. In mountain test. You can see that system, it is like this from here. You can see how the it is. This is accelerometer. To get the correct orientation, he is just having this extra tool so that he is aligning in the direction of its structure. Now he started giving input. You can see that it started moving. When it starts moving, all the accelerometers or the instrument, the sensors that are placed are collected into a data system. They are processed. There is some kind of processing required for it to display in the form of mode shape. What we call FRF, frequency response function. Once that frequency response functions are collected and then processed, this is the input varies near the engine. This is what we call as kind of rod. It is called stinger. And now see, he is processed and then he is getting the information. This is what we call the mode shape finally. So that gives some kind of validation of the design. Right. And before finally closing it, see, for all of them, you need some kind of instrumentation, what we call accelerometers. So there are different kinds of accelerometers. I will tell a few lines. Basically, if you say piezoelectric accelerometer, it was some piezoelectric effect. What it means is, whenever a force is applied on a piezoelectric crystal, then kind of charge output is produced. See, the charge output can be converted into voltage or it can be taken as it is. So they are called either charge accelerometers or say voltage accelerometers, depending on the type of output that you collect. If you collect directly charge output, you call charge type. If you collect voltage, it is called ICP. Again, because you are giving input in one direction and taking in one direction, it can be uniaxial sensor. But you can also have triaxial, means in 3 directions. Again, there are different types of accelerometers like piezoresistive, variable gate accelerometers, capacitive. This means capacitive. Depending on which phenomena is taken to measure the input. If it is resistance, it is piezoresistive. Capacitance, it is a capacitive accelerometers like that. Resistance and capacitive accelerometers can even read DC, but visually cannot read. So then some parameters which influence the like frequency range, what is amplitude, weight, temperature, all these. Apart from that, finally when you do some kind of instrumentation, you need to know some kind of calculation, which means whether whatever you are measuring is correct or not, that you should know. Again, I have told you a lot of vibration data. What all we do in vibration data analysis means, so you have raw data coming from the sensor, then you use some kind of filters, then you do sample at some kind of sampling in the data part, you convert it to this, then you come to, you apply some kind of window, you use the FFT, then convert it to PSD form that we wanted. So this is the process that we follow. While doing this, acquiring a signal, you may come across something called aliasing. Means your signal is like this. If you can pick every point like this, it will represent that. But by mistake, if you are represented like this, that means you are aliased into some other signal rather than this signal. So to avoid that, you need some kind of rules which ask you to sample more than 2 times the maximum content of the frequency signal. So again, windowing again to avoid spectral leakages, because FFT means you should have infinite signal, so repetition should be there continually. So you apply, window is like multiplying one function with the other function to avoid spectral leakages. These are the things that you should know when you are doing vibration analysis. Thanks.
I have a couple of doubts, sir.
Yeah, please.
Vibrations in regard to aerospace, sir. Aerospace.
Yeah.
Sir, MH370 Malaysian air flight.
Yes.
8th March 2014. We are in 2015, highly sophisticated world. Then why we couldn't raise anything about it, sir?
No, I was covered only. Yes, you are right. Your question is right. We actually don't know exactly what happened there. When we have data only, we can talk.
Like you have done so much of testing on Airbus 380, sir.
No, I have not done. I have shown, I told you, this from the internet. See, I am doing only with respect to missile systems. If you ask me anything about missile systems, I tell. Whatever I have shown, Airbus, it is not my work. I have told you that. Sorry. Airbus is, I have taken it from the net. I have not done. I am working in missile complex, where our job is to do missile related testing. I have shown you so many testings related to missile. That is my contribution. Airbus is to enhance your knowledge. I have put Airbus or what they do in contemporary world, like we are doing three missile model testing. We also should know what others are doing. So we refer it to the literature. So that's how I have shown you Airbus 3. I'll tell you, MH when it has failed, no? They are searching for the black box. First Malaysian airplane what is lost? They are not able to trace where it is lost. Every system, no? These are all sophisticated systems. Whatever you do, yes, there are going to be bugs. 100% we can't ensure. If you do 100 tests, no? You may solve 100 problems, but there are going to be one problem which is going to come. We don't know.
Sir, last doubt, sir. In one of your earlier slider, the beginner slider, sir, you said something regarding to environmental conditions, and you rated one parameter as electromagnetic.
Yeah,
so
EMIMC. Electromagnetic interference or electromagnetic compatibility we call.
I have a doubt regarding that.
I tell you, for example, your mobile phone.
Yes, sir.
You go near to the TV. When mobile rings, have you noticed TV starts blinking? Why? Because the frequency, the content of the waves, no? They are electromagnetic waves. You are not able to visually see, but the waves are interfering with that TV channel signals. So we are going to put hundreds of systems in my missile section. There are going to be 100 systems. I should be fully aware one functioning of my system is not interfering with the other system. So we do testing that. I have not done any test, that's why I have not showed any test. I am not in that division. I am in the vibration shock, so I showed that. But electromagnetic interference is very important criteria, because you are going to put so many systems side by side. No? In fact, after all, your mobile and TV, when you are bringing together, you have a disturbance. Now you think of our position where we have 100 systems together, but we should not feel such an interference. Then how do I design?
It's almost equivalent to rocket science, sir.
We are doing last
we have been talking about electromagnetic things, sir.
Yes.
Do you have any clues, sir, on Bhadra triangle? Where so many of aircrafts and ships have been
Yeah,
launched.
no.
And
That is
the main reason was electromagnetic.
They are calling it non-magnetic. They say it is some kind of where you don't like that is a black hole. It is a mystery, not solved.
Not solid. Thank you so much.
Sir,
Yeah.
sir, for this surface state within an aircraft results you have something, but what about torpedoes? How you test, sir?
Yeah, torpedoes also. Why I am not sure torpedoes is the same way we test. But torpedoes, no, actually, NST and Vizag is responsible. Naval Science Technology Laboratory. We are responsible only for missiles. Yes, we have tested some kind of torpedoes. When they did not have the initial facilities, we did. Same way, torpedoes there is nothing different. We consider it as one system. Total system we have to consider. The range will be different. Yes, your frequency range. The torpedoes are going to be carried by ships. So the ship environment we have to test it. If it is a missile. Missile is either carried by aeroplane, helicopter, or by this thing. So that environment will be down. So the environment will be different, but the kind of methodology of testing will be same.
Sir, one more small doubt, sir. So means how will you track them? How will you fix the target, sir, in that?
Missile.
How will you sense?
Missile.
How the missile senses the target and
Different
which is
missiles.
there?
If it is a ballistic missile, suppose surface to surface, depending on the range, we have ocean. Say, we always put it in the ocean, bare in the ocean, so that it doesn't affect people. Say if it is 1,000 kilometers range target, we position ships there. Our people will go there. We have a designated target there. We call downrange antennas are there. They are positioned at Andaman, some information I can do. Okay, they are positioned at different places. Okay, they track continuously. Radar networking system is there for us. So we track continuously. It is not that we are saying that it goes. A target for every mission there is a target, designated target put at that place. And when this fellow goes and hits, whether it is hitting or what is the error, that we check it. That we.
Sir, it's like
Radars are used basically. What we call it the radars.
sir, in Orissa will be testing missiles, sir. At that point, means we will target the ocean or to the ships or.
Always no, we don't target it. We put our target, designated target. Some kind of system we put there. We can't target ships. They will fire us again. We can't do that. We should take clearance before launching. We should take clearance from all the neighboring countries, SAARC members, and so many other logistics things are there.
Thank you.
Hello everyone, I would like to extend our thanks to Veera sir for giving a constructive and wonderful presentation on dynamic testing of aerospace structures, vibration and shock. Thank you sir for being here with us today and sharing your knowledge. Occasions like this are always moments of thanksgiving. I would like to thank our faculty who played a great role in organizing the session and to all those who have contributed in one way or the other to make this program a success. Thank you.